session on ANSYS Workbench tutorials. In this session, we are going to analyze a disc brake rotor for its thermal and structural analysis coupled together. So we will start by double clicking on static structural. We will first go to engineering data sources, general materials. I am going to use stainless steel as the material. I'll update. Next, I'll go to geometry and right click. I will import the geometry of the disc brake rotor. Next, I'll go to model and double click on it. I'll first go to geometry and change the material to stainless steel. Next, I'll go to mesh and I'll change the sizing to fine and update. In this type of analysis, when I say it is coupled, it means that the same disc brake rotor is going to be subjected to both type of analysis, one after the other. You can either go for thermal analysis first and then the structural analysis, or you may go for structural analysis first and then the thermal analysis. It depends on which factor is affecting the other one. So I have started with the static structural analysis. I will now go to static structural and I will right click and insert fixed support over here. On this phase, I am going to insert pressure of say 0.5 megapascal, and also on the other side I am going to insert pressure of 0.5 megapascal. Also on this phase, I am going to insert rotational velocity. Say the magnitude of rotation is 55 radians per second and the axis is this phase applied. So you can see here rotational velocity has been applied. So this is as far as the boundary conditions are concerned for structural analysis. I will now go to solution and I'm going to insert deformation total. I also want to see the value of strain over the body and also the value of stress. If you want, you can see here stress tool such that you can see the safety factor of the body. I'll go to solution and solve it. For stainless steel as the material for this disc brake rotor, I can see that the total deformation is 0.001748 mm. This is how you can animate and check your results. It's only on this surface that you can see the deformation. Next, you can see the value of strain over the body is 0.000123. You can animate and check the result. This is the maximum amount of deformation over the body. The value is really very small. It's just the exaggerated thing that you can see here. Next is the value of stress. It is 23 megapascal. Again for stainless steel, which has a very high value of tensile stress. The stress value is very high. 186 megapascal is the value. So 23 megapascal is compared to that is really very small. So this is how you can animate and check the result. When you go to safety factor, you can see that the body is completely safe. It has a very high value of safety factor, that is 15. So once this is done, this completes the structural analysis of this body. Now do not cancel the window, just leave it as it is. You can go to steady state thermal and just drag and drop it over the body. So all the results that you have over here will be now transferred to the next analysis. So I'll just go to setup and double click on it. You can see that the static structural analysis is already present. Now you're going for steady state thermal analysis of this body. So you can go to steady state thermal and insert its boundary condition. So I will start by giving a temperature to this body. Here I'll give a temperature of 80 degrees Celsius, and I'm going to give convection to this body at this point by choosing temperature dependent option. I'll choose the first option. Next I'll go to solution and I'm going to insert thermal temperature. I also want to see the result for total heat flux. I'll now go to solution and solve it. So once you click here, you can see the temperature over the entire body. You can see a beautiful variation over the body. This is the total heat flux value over the body. You can see the total heat flux maximum value is 0.00077 watt per mm square, and the minimum value is 1.3363 into 10 raised to minus 8 watt per mm square over this entire disc brake rotor. So that's how you can analyze a combination of structural and thermal analysis over the body. These factors definitely affect the value over here. So it is used when you want to have a combination analysis over the body, such that you know what would be the effect of a particular condition on the body, and then the subsequent effect on another type of analysis. So with this, I end the session. I hope you have understood this analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.